Giovanni Enrico Loni from the University of Pisa, and his talk will be about sync your tunes, sync your screen, and introducing SyncWall. Welcome.
Yeah, thank you for the introduction. Yeah, well, I'm Giovanni Enrico Loni, and I have the pleasure to host this session in which I'll share with you some details about my project called Spotify SyncWall, or for brevity SyncWall. First of all, what is SyncWall? It's an application that generates for you wallpaper based on the song you're listening that very moment on Spotify. And let's have a look of some examples. So you are sitting on your desk, you're working on your PC, and you would like to see some kind of things that reminds to you what the song you're listening on Spotify at that moment, because of course you can work without music. And you have a look on your desktop and you see an image taken right from the music you're listening to, because we see the cover of the album, and you have many modes to choose from to generate the image. For example, you can have an image based on the actual image blurred, or again a waveform based on the loudness of the song, so you can recognize the patterns of the song in this image, the volume of the track. Again, you can have a gradient based on the most popular colors on the image of the album, and then you can draw a gradient and apply then again the cover. You can also have a fake progress bar. You can pause the song by touching the pause button, but yeah, it's kind of like Spotify. And then one of my favorite, it's get the lyric of the song, the chorus of the song, so you can sing along in your desk while you're working, while the chorus arrived. So what's the application workflow? How the application can perform all of these operations to generate the image and apply that image as wallpaper. So first of all, we have to start listening music on Spotify, obviously. In fact, there is a small procedure to connect your application, your local instance to the Spotify API in order to retrieve your real-time data, such as the song you are playing and other stuff useful for later. And the application checks every second for the song you're listening on Spotify, recalling Spotify API, and then if he found that the song is different from the previous one, then it starts all the operation to generate the new image. So it chooses a random mode from the one we saw in the previous slides, and then starts the actual operation to generate the image, which are different for every mode. In particular, I'd like to share some insights and challenges I've faced while I was developing the app, in particular for two modes. The first one is the waveform mode. As I said earlier, is based on the volume of the audio track. In fact, the operation don't work on the actual audio of the application, because you can download it from Spotify, but you can download a song audio analysis using Spotify API. This file contains information such the key of the song, the BPM, and also an array containing the loudness levels for each the duration of the song. There are about some 2,000 levels. Obviously, we won't use all of them for too many reasons, because analyzing all of them will be very slow. Will take too much time, and this is unacceptable in a real-time application, which is SyncWall. And secondly, we don't have such a screen big enough to contain all these 2,000 samples. So we took a small part of them, about 100, which are enough to generate a good-looking waveform. Then we convert this data from logarithmic scale to linear one because loudness is expressed in decibel, and we know decibel is logarithmic. And even if we don't convert to linear scale, the waveform will be very flat because values tends to be all similar, and it is not the ideal what we want for a good-looking image. And lastly, you draw these levels by using lines. And this is the process in different phases. You can see vertical lines, which represent these values of volumes. Shorter lines represent, obviously, lower volume, and bigger one, a higher volume. And this, after analyzing this data and generating this waveform, this is actually placed in the middle of the image and then placed as a wallpaper. The other mode I'd like to show with you is the gradient one, because the Python library I use to manipulate the images, which is called the Python Images Library, or PIL, don't have an actual function that output an image as a gradient. So I needed to build on my own method to generate this gradient. So I was able to generate a gradient of an array of colors that represent the gradients between two of these given colors extracted from the image cover image, and then draw lines which with each of one with a different color, which is taken from this array of color representing the gradient. And the same thing can be done also with circles, so a gradient with start from the center, then spread until the edges on the image. And then you can see the hole in the middle because you put there the image of the album, so you won't draw any more circle because of optimization of performances. And the last step on the application workflow is to apply the wallpaper to your system. In fact, this was the most challenging part. This mainly because of the high number of desktop environments available on Linux. This application at the moment is only available on Linux, and in particular only on GNOME desktop environments, because each desktop environment handles differently the wallpaper. So for each of the desktop environment, you will need to know the right command to set the image, an image as a background, and retrieve the path of the image set as a wallpaper. And given the fact I only use GNOME in my Linux system, I wasn't able to implement for this function for other desktop environments. And in fact, this is the first point of the roadmap for this project. I'd like to find someone who is interested on the project to help adding the desktop compatibilities for other desktop environments, such as KDE and so on. And in a similar way, I'd like to add also a macOS compatibility. The code used to generate the images is absolutely independent from the system you're using, so because it's written in Python. And so performing the image manipulation on Linux or macOS or whatever doesn't change very much. The only difference is the handling the window manager, the desktop environment, so handling again with setting the wallpaper. And given that I don't have a Mac, I can't even try to implement this functionality on macOS. So as before, if you're interested, you can get in touch with me to develop this feature also. Another point is the GNOME extension. As I said, I use GNOME, and as desktop environments, it offers the possibility to install extension, which basically add some functionalities to the desktop environments and the usage, and implement the application as GNOME extension will be let the user use the application with ease, without any difficulty. And the last point is to add new modes. This because I'd like to offer some measure variety on image the application is able to generate, and to have also even more modes for the same song you're listening to. And this is the end of the showcase. As I said at the beginning, I'm Giovanni Enrico Loni. I'm studying at University of Pisa. You can get in touch with me basically in any social media by using this handler, and scanning QR code. You can directly go to the GitHub repository if you want to have a look at the code, some other insights. And again, if you want to get in touch with me to have some other questions or even collaborate with the project, I'll be around at the conference, or then again, you can write me on social media. Thanks again.
Thank you very much. Are there any questions? There they are.
You talked about support for different machines or for macOS, but is there also support for, do you plan support for other services like, I don't know, YouTube Music or Apple Music or general other music apps?
At the moment, no, but only because it's like a personal project, and since I use only Spotify and GNOME, at the moment it wasn't worth to give an effort to develop for other platforms I don't use, mainly because of troubleshooting. Maybe I can write something that barely works, but I then can't able to solve some problems that can present. For instance, there are some limitations on Spotify API, and even for Spotify that I use daily, there are still are some problems. So I can add the support, but not alone. This is all the point of the presentation. But thanks.
Okay, thank you. Other questions? No questions so far? There's a question.
Hi. What kind of API Spotify gives to you? What is the body of the response? Like you have the text of the song and the landing page of the song, and what else?
Okay, basically I performed only two different requests on Spotify. The first one is to retrieve the song you're currently playing. I don't remember the exact name, but it's something like that. The currently playing song, and the response is the ID of the song, the URL for the cover album, which I use to retrieve the cover. And then another request is the one I use to generate the song analysis. You have to perform a specific request, and the response is a JSON with these loudness levels and other information. And the one I use to generate the lyrics, I don't use Spotify, because Spotify doesn't provide any API for lyrics. I use Genius, which is a website that contains lyrics for songs.
And how do you sync the music that is going on and the waveland and or the text?
No, it's not synced. It's a static background.
Okay.
For this mode, I retrieve the lyric and then extract the chorus using a regex. And this one is not synced with the song, but you can recognize the pattern of the volume if you know the song, obviously, but it's a static image.
So, okay, static. Thank you.